Assalamu alaikum. This is Dr. Nosheen Tariq Siddiqui. Today we are going to start a new topic, that is rheology. So what this rheology means? Rheology basically derived from Greek word that is rheos, which means flow, and logos, which means science or knowledge. It is the study of the flow of deformation of matter under influence of stress. Rheology can be applied to solids, completely resistant to deformation, liquid, which is moderately resistant to deformation, and gases, which is completely not resistant to deformation. What does this mean? That rheology is basically, it is a study which is involved or which is about the flow of a material. In the rheology, we are going to study the flow of material. That is, as the definition says, that it is the study of the flow. Of the flow, which thing? Materials. There are, of course, there are three types of materials. We know the common type of materials: solid, liquids, and gases. If we study rheology and if we apply rheology to solid, means that it is completely resistant to deformation. It means if you apply any force to it, you will not find any deformation in it. So rheology can be applied to solid, but it is completely resistant to deformation. While liquid, they are moderately resistant to deformation. They resist deformation, or they tend to resist, or they tend to resist to shape their to deform basically. While gases, they are completely non-resistant to deformation. They are good for deformation purpose. Basically, what is important, or the general elements which for general elements which you keep in mind, or which you should keep in mind while studying rheology. There are four elements which you should keep in mind, or that we have to consider when we are studying the flow property or material or for deformation. Number one is the material inner own structure, that is what material is made up of. The material's inner structure, how is the material built, and what is the molecular makeup of the material. We have to keep that in mind. What is the number one element which we will keep in mind? The material's own inner structure. What is the second? Is the morphology. Morphology is basically where molecule associate and bond with each other. We have to keep in mind about the molecular structure and about the bonding as well, how the bonds are basically associated with each other, and what is the shape and size of the molecule. Okay. If we go in the example, then example is that materials are composed of small, if you can say that certain times the materials are composed of small needle-like structures, or in needle-like structures or crystal formation, you can say. And sometimes the molecules are bulky, or they are like cotton candy type. You can say that they are bulky type of material. So both these types of material can come into the morphology. Number one is the material inner structure, how it is made, the molecular inner makeup, and certain times the morphology means what type of, what the shape and the size of the molecular structure is. Number third is the outside force, that is the stress that the material is causing or you are putting to deform or flow the material. The outside force, what you will keep in mind while studying rheology: the inner material, how the material itself is, and what type of pressure or force is you are putting on that material. So what it will do, it will either pull apart the molecules inside, or it will be compressed more, or there may be some other force like shear force, etc. Okay, so we have to keep this thing also in mind. And number 4 is the ambient condition, that in what environment you are basically the material is in, like in what environment. Maybe it's a stressful environment for the material, or it's not a stressful environment for the material. Like, if you take water, so you can say that water will behave different at different temperatures. So the material is same, but the thing which you are applying, or the environment which is in, is different. That is it will behave differently at different temperature. Okay, so what you are going to keep in mind, the material in a structure, the morphology. If we say it in points, so morphology, the outside force which you are applying, and the ambient condition. So if you can say, if we go, if you'll notice, if you'll write a comprehensive definition of rheology, then we can say that rheology is the study of the flow of matter, primarily in the liquid state, but also in soft, solid, or solid under condition in which they respond with plastic flow rather than deforming elasticity in response to an applied force. Means it is the study primarily for the liquid, but also for soft solids or certain types of solids which are under condition in which they respond with a flow that is called a plastic flow. Means they don't actually deform, but they flow actually. That flow is called plastic flow. And elasticity is basically responsible for that applied force. It applies to substances such as, if we say, if you see different types of materials. You see there is a woman, she's putting mud on her face. How she's able to do that? Why mud? If you see mud is in a state, in a solid state, it don't, you cannot apply it just like that. But when you put water, it's, and you mix it, then she is able to apply that or spread that over her face. How she's being able to do that? Or you make a suspension, or you how you are able to make that suspension. All these things, you'll study in rheology. You also, have to keep in mind the viscosity of certain thing. You have to know what is viscosity and how this viscosity builds up with time. Because certain times, viscosity builds up, and certain times the viscosity does not build up, but it breaks. How it breaks? You must have noticed that if you apply force if you have a ketchup bottle, if you shake it, then the ketchup will come out easily. So you are kind of when you are shaking or putting pressure, the liquid is coming out, and when you keep it aside and you keep it for some time, it will again have that kind of thickness again. But if you apply or shake yogurt, then yogurt will thin, but you will not be the same thickness will not come again. But like in creams, creams have totally different behavior. When you take cream and you whip that cream, and before whipping it is kind of a liquid, but after whipping it, it gets stiff, and that's how you're able to put it on cakes and cupcakes anywhere. So that behaves differently. So it is, you can say, a strange kind of topic, but rheology helps to explain all these phenomena which I have just discussed or gave you example, because this rheology is this explains many things which we encounter in everyday life, or in everyday phenomena we encounter to these types of things. And it also, while study or while the knowledge of rheology, you can manipulate liquid. For example, you can make different things out of it after the understanding of rheology. For example, if simple thing is that if you want to apply a varnish on a furniture, so you should know the spreadability and how the liquid is performing while you are putting the pressure on it. So that's how you're able to understand what liquid is behaving and how perfectly you can use it. Same is the case of in pharmaceuticals as well. If you see that if you have an injection, you know that injections, they are easy to administer. You make them more comfortable for the patient and the nurse, for the patient to for the ease of their administration, and for nurse to to dispense it. So the injections are made in such a way that both patient and the nurse will be comfortable with your preparation. How you are able to do that? Because you are basically uh, making the use of rheology, and after putting these rheological principle in use, you can also you can also have effect on the dose of that drug, because you can minimize the frequency of injection. Say from, if somebody is getting once a week, it can be shifted to a single dose a week, to a single dose to a month. So it all depends on how you are preparing your pharmaceutical preparation. So it will affect on how it is dispensed and how it is the dose. If you first, you will have to have a understanding what is what is viscosity, or what is simple flow. For example, if I've given you a picture, these are three hose pipes in which water is flowing. If the water is flowing in the number one, which is said the laminar flow, the water molecules are flowing in very orderly fashion. That we are the water is flowing in very orderly fashion, that it is called, no pressure is given, but the diameter of the hose is similar, but the flow is different. So you can see that the water molecules are flowing in very orderly manner. This is known as a laminar flow. While the third, or the turbulent flow, in that you're putting some pressure. So the water molecules is flowing in a disorderly manner, or you can say in a turbulent manner. This is called the turbulent flow, while transition is in between the turbulent and the laminar flow. Have you noticed that why it is like that? That why when hose is similar, why water is flowing so differently in each of them? Why it is different? Because of the velocity. Velocity, basically, this has to do with the how the fast the water is basically flowing. The faster it flows, the more likely it is turbulent. The slow is formed, it is least turbulent. That is, it is flowing in a very orderly manner, then it is called the laminar flow. There are of course other factors that can affect of a liquid. Not only this velocity will affect, but there are other things which also affect this liquid, or the flow of liquid, which is density, viscosity, and the diameter of the hose. These all things also will be dependent. On the flow, what are the other things which are dependent? The density of the liquid, the viscosity of the liquid, and the diameter of the hose. There is a scientist which combined all these variables, density, viscosity, and diameter, which we are not going to study that, but his name was Reynolds, and the equation he derived, it is known as Reynolds number. If the Reynolds number, it is said that if it is less than 2000, then the liquid is likely to be flowing with the laminar flow. And if it is greater than 4000 or above 4000, then it is called the turbulent flow. Okay. So what we can say till now is that in rheology, we have to keep in mind different things. First, we'll look on the pharmaceutical technology. Rheology measurements are involved in the following things. We should know how and where we are applying this rheology thing or rheology concept. In pharmaceutical processing operations, such as mixing of materials, filling and packagings into containers, here rheology applies. What pharmaceutical processing operation you are applying to mix a material? Because when you are mixing, you have to keep in mind how you are doing that mixing, because due to that mixing, your material is going to be changed. Like as I gave you example, that if you apply force and pressure and you whip up cream, the materials, it changes. The appearance of the material changes. So you have to keep in mind the pharmaceutical processing operations, such as in mixing of material and how it is going to be filled, filling, and packaging of the container. Because what type of material, every type of material has a different packaging, because you don't need to only pack a material only. Your main purpose is for the dispensing as well, how the thing will be dispensed. Okay. Removal of product from packages, such as pouring of a bottle, extrusion from a tube, spraying liquids from atomizer, or passage from syringe needle. The next thing, which of course, after mixing or making, the removal of product from the package is very important. If you have made something and it's not coming out from the bottle, then it's useless. If you're keeping it in a bottle, then you are going to, of course, you have to make a different packaging for that. But if you are making certain thing which is already being dispensed in a bottle, then you have to make it in a form that it should keep its the consistency and the thing which is appropriate for a bottle. So removal of product from packages, such as pouring from a bottle, extrusion from a tube, spray liquid, extrusion from a tube, spraying liquid from atomizer. It's very important while performing these types of things, that you are when you are your pharmaceutical preparation is coming out from a tube. It's very important you keep that liquid in such a form that it can easily come out from the tube. Or spraying liquid from an atomizer, if you are making you're spraying your product with something, so the liquid should be in such a consistency that it should be uniformly coming out from the atomizer and passage from syringe. Or if you talk about injection, then it should come out evenly from the syringe needle and should not clog the needle. So you have to keep in mind the flow property of that liquid. So topical application of product into skin, how this is important, because you need you can say a very smooth covering or a very uniform covering over your skin, because you need your product to be spread out completely onto your skin. So for that, you need to have that your liquid or your semi-solid or cream, whatever, that it should have a consistent product that it spreads out completely on your skin. For that also, you have to keep in mind the rheology. Physical stability of suspension, emulsion and semi-solid. Of course, when you after studying rheology, you will be able to have a stable product of suspension, emulsion and semi-solid. These all things, they include two phases, which are solid phase and liquid phase. So when the two phases, you have combined two phases, you have to keep them in an equilibrium or in a balanced position. How you are able to do that? You will be able to do that after studying rheology, or you will keep in mind the rheological factors. So you will be able to have the physical stability you require for suspension, emulsions and semi-solids. The next thing is bioavailability. Since viscosity has been shown to affect the absorption rate of drugs, so of course, if your product is, your viscosity is important for absorption, then of course, it will affect the bioavailability of that drug. And lastly is the release of drug from dosage form and delivery system. How the drug is releasing from the dosage form and delivery system, it is also affected by the viscosity or the rheology of that product. There are some fundamental concepts. I've already told you some concepts, but the main concept which you should keep in mind during the formation of rheological products, or the products which have different property while you are making them or dispensing or preparation, during preparation. This is elastic deformation and viscous flow. The deformation of matter under influence of force or stress can be described by two components, that is elasticity and viscosity. Basically, if you say that there are two types of things, liquids and solids. If you don't see in between what it is that when you omit seeing that viscoelastic something, if you keep in mind if there is something liquid and solid. Liquid is something which is easily flowing and which has or character of its own. If it's a liquid is with no such viscosity, then you can say that the flow is good. Liquid usually flows, but in solid they don't flow basically. So, but not everything is, is like that they can flow or don't flow. Not everything is liquid and not everything is solid. There is something in between as well. These are called as viscoelastic substances, in which, this is the creams, the lotions, the oils, and the like honey, and you can even say the tires, they have these type of things, they have different kind of in some cases the viscosity is higher, in some cases the elasticity is higher. Like in lotions, you can say the viscosity is higher, while in tires you can say the elasticity is higher. So these compounds are viscoelastic substances. The example of the viscoelastic substance can be, from the ointment to shampoo, cream, jellies. There are numerous types of examples, which is neither liquid completely or they are not solid as well. But yes, in rheology, you can say that it applies mostly on these viscoelastic substances. Nearly every material is made up of viscous portion and an elastic portion. These viscoelastic material, or the every type of material which we encounter in life, it usually it basically consists of nearly two things, that is viscous portion and an elastic portion. The material is more viscous, then it is a liquid if a material is more elastic than it is a solid. If you just keep in mind, if the liquid material is more viscous than it is a liquid, and if the material is more elastic than it is a solid, the material will with higher viscosity portion are called viscous liquid. The material with high viscous portions are called viscous liquid, and they are also known as Newtonian liquid. And it says that at constant ambient condition, no matter how much is the stress, the Newtonian liquid will always show the same viscosity. Means no matter how much you put stress on a Newtonian liquid, it will always show you a same viscosity. While viscoelastic liquids are liquids with an elastic portion, whenever these materials are stressed, they flow, but they also exhibit a certain level of stiffness. So viscous elastic liquids they are liquid with an elastic portion, and when the material are stressed, they flow, but they also exhibit a certain level of stiffness. While viscoelastic solids that are not too viscoelastic solids are deformed by an outside force that is not too large, because it can break also. If you put this on viscoelastic solids, if you put outside force, the inner structure of these materials slides to either to slides, but it slides together, but it returns to its original position as well. So that's how they are known as elastic solids. Elastic solids always show the same level of stiffness as long as the structure is not destroyed. Generally, when we think of liquid, we say that viscosity is one of the aspects of rheology. So rheology is a measurement of of flow of liquid. Because the elastic solids have that kind of structure, so we cannot say that it will be affected by rheology. So the rheological study is basically of liquid and viscoelastic liquids. We'll define some aspects, that is elasticity. Pure elasticity is achieved if the shape of the body is restored once the force is withdrawn. It is, वैसे तो ऐसे हमेशा होता नहीं है, but एक general concept के लिए it is like that pure elasticity is achieved if the shape of the body is restored once the force is, when you withdraw that force, the shape of the solid will be, regained. So elasticity is the property of solid materials, and Hooke's law is used to describe the elastic deformation of solids. This is Hooke's law. I've only, put it here for your knowledge. If stress is directly proportional to strain, the body returns to its original shape and size after the stress applied has been relieved. The proportionality between stress and strain is quantified by the constant known as modulus of elasticity, or Young's modulus. It is known as Young's modulus, and its unit is Pascal. What it is said that the proportionality, it is the proportionality between the stress and strain, okay, and it's a constant. What is viscosity? Viscosity, pure viscosity or pure viscous flow occurs if there is a continuous movement during the applied force. Pure viscosity or pure viscous flow occurs when there is a continuous movement when you have applied a force, and it will not come back to its original position. It does not have that elasticity, and no restoration motion occurs once the force is withdrawn. Okay, if the agar wo hota hai वापस withdraw, that means it is an elastic thing, but viscosity does not go like that. So it does not will not restore the restorative motion नहीं होगा उसका, ठीक है. Viscosity is the property of liquid material to undergo permanent or irreversible deformation, and is explained by Newton's law of viscous flow. This is Newton's law of viscous flow. To understand the fundamental concept of viscous flow, consider this figure. Two parallel lines are at a distance apart, which is dx. The viscous body is confined between the planes. When force F is applied to top, a plane A moves horizontally with the velocity dv, but the lower plane remains motionless. This is Newton's law of viscous flow. Okay. What it will happen when you apply a force on the upper portion or the top, the upper portion will move with a velocity, that is v, with a distance which is dv, and the distance between the lower while the lower portion will be stationary. As a consequence, there exists a velocity gradient, that is a velocity gradient will be uniform because the upper portion is moving and the lower portion is not moving. So a velocity gradient will be formed, which is this velocity gradient over distance is known as this will be dv upon dx, because it is there is a gradient which is built up. This velocity gradient over distance is known as the rate of shear. This velocity, the difference is known as the rate of shear, which is the denoted by capital D. The horizontal force per unit area creating the deformation is known as shear stress, which it is per unit area. The force which is applying horizontally, this is known as the shear stress, and it is denoted by S is F upon A according to the Newton's law of viscosity. There's one more equation which I will write it on the board if I'll take your class. Okay, this is our last slide. What is the classification of fluid based on rheological behavior? There are two types, basically Newtonian and non-Newtonian. There are two types of fluids according to based on their rheological behavior. According to their behavior of rheology, the fluids are of two types, Newtonian and non-Newtonian. Newtonian is again, non-Newtonian is again. There are of two types, time independent and time dependent. The time independent are plastic, pseudoplastic and dialent. We will discuss it later. And the other is the time dependent, which are thixotropic, antithixotropic, rheopexy, and negative rheopexy. Okay, that's all for today. Inshallah, we'll continue this lecture in our class.